Hi, everyone. I'm combining a couple of sections from textbooks. We're going to do exponential and log equations and related models, answering related questions. Okay, so first of all, one thing that's going to help us a lot in terms of solving these kinds of equations will be the one-to-one properties. Okay, now what's the basic point of the one-to-one properties? Well, in terms of your actual work, if b to the m equals b to the n, where b is a nice base, positive and not 1, then we can basically equate the exponents, m equals n. Likewise, if we have log base b of m equals log base b of n, where m and n are positive in value, right, then we can say that m equals n. Now, going from right to left, that's trivial, right? For example, if 3 equals 3, then b to the third equals b to the third, log of 3 equals log of 3, whatever the base is. But what's non-trivial is going from left to right, because it's not necessarily the case that you can set things equal to each other just because you feel like it, just because it looks like the right thing to do. So let me give you an example of when it doesn't work out so hot. All right, so for example, let's say that we have x squared equals 3 squared. X squared equals 3 squared. Okay, now, can we just automatically say that x equals 3? X equals 3? Is that going to be correct? Well, not necessarily, because x could also be negative 3. So it is not the case that just because these two things look like they match up, it does not necessarily mean you can equate them to each other, okay? Yes, x could be 3, but x could also be negative 3. Now, why is it that we cannot match things up here? The problem is that the squaring function is not one-to-one. I'll explain using Desmos. Let's graph y equals x squared, okay? Now, I'm going to plot 2 points here, 3 comma 9, which we know is on the graph because 9 is 3 squared, and also negative 3 comma 9, which we also know is on the graph because 9 is the square of negative 3 as well. But that's exactly the problem. We have two values of x, 3 and negative 3, that yield the same value of y equals 9. I'll even put the line here. See, the problem is that this parabola, the graph of y equals x squared, it fails the HLT, the horizontal line test. As it stands, the squaring function is not one-to-one. The graph fails the HLT. Now, if the graph is not one-to-one, then we have this property that two x-coordinates can yield the same y-coordinate. So, for example, it's true that the square of 3 is 9, but the square of negative 3 is also 9. Okay, so here's the problem with just setting things equal to each other just because you feel like it. If you have a function that's not one-to-one, then that tactic may not work. Because if the square of x equals the square of 3, actually x could be 3 or negative 3. So when does this matching actually work? It works when you have a one-to-one function. For example, let's look at this over here. Y equals 2 to the x. Now this is a graph that passes both the VLT and the HLT. The 2 to the x function, this exponential function, is a one-to-one function. It passes both the VLT and the HLT graphically. So for example, if I plot the point 3 comma 8, which I know is on the graph because 2 to the third, when x is 3, is 8, y equals 8. Okay, so if I consider the horizontal line y equals 8, it only passes through that one point on the graph. So if I wanted to solve the equation 2 to the x equals 8, well, there's only one solution. X equals 3. It's right there. X equals 3. X cannot be negative 3. Negative 3, 8 is not on this graph. So 2 to the x equals 8. In particular, I could have said 2 to the x equals 2 to the third. 8 is 2 to the third. Well, if 2 to the x equals 2 to the third, Desmos knows, actually, that means that x equals 3. You can equate the exponents. These do match up. And that's because of the one-to-one properties. If 2 to the x equals 2 to the third, then x equals 3. Of course, the bases must be the same. If that's a 2 and that's a 3, this doesn't work out. All right. Now, it turns out that we can really use these properties to solve exponential equations and logarithmic equations later on. And we'll see that in the next lessons.